We're asked to find the principal root of the complex number minus 1 minus I raised to the 1/4 power, and then express it as a rectangular form in a plus bi with a and b both rounded to the nearest hundredth, which we will find out is a little tedious, but we go where they ask us, right? So our very first thing is that we're going to use the Moivre's theorem, and we're going to want to convert this to polar form because that is way easier to do for the Moivre's theorem. So I'm going to want to convert, if I say my original guy is minus 1 minus I, I'm going to want to find r and theta for that guy. So remember that r is going to be the square root of the x-like thing squared plus the y-like thing squared. Also remembering that the I here is a flag for us, but doesn't go into the expression. So we have the square root of minus 1 quantity squared plus minus 1 quantity squared, which is the square root of 1 plus 1, which is the square root of 2. And the angle is the arctan of the y-type thing over the x-type thing, so minus 1 over minus 1, or the inverse tan of plus 1, which a calculator would tell you is 45 degrees, but we know we need to add 180 degrees because x is less than 0. So we end up as a whole at 225 degrees. Then de Moivre's theorem says that raising something to a fractional power raises r to that same fractional power, but only divides the angle. So if we want to take z to the 1/4 power, we're going to take square root 2 and raise it to the 1/4 power, and we're going to take 225 degrees and divide it by 4. This does not have a really pretty way of going. I suppose technically that's 2 to the 1/8 if we want to look at it that way. And this comes out to be 56.25 degrees. And before we go any further, that is an answer. That is the principal value of that, the quartic power of that number. But it isn't what they asked for because they want it in rectangular form, which is a little annoying and is a whole different step that I'm going to do on the next page, but isn't really related to the problem, which was to find the principal root. It's only because of the particular way they asked us that. So what we have now is really just a exercise in converting the cis stuff back into rectangular things. So we remember that this guy's going to come for a ride, and it's just inconvenient. That cis literally means cosine plus I sine. So we're going to have cosine 56.25 degrees plus I times sine of 56.25 degrees. And in the end, that's just going to be thrown into a calculator anyway. When you do that, you end up getting something like 0.61 plus I times 0.91, which is not particularly informative, and it's not really clear why the textbook wanted you to go there, but there we go. That we can now say that this is the principal value of the fourth root of minus I to the 1/4. Principal value is approximately 0.61 plus I times 0.91. Done.